Hey guys, welcome back. So we're testing our PWM fan controller. So we got it hooked up to the 50 amp power supply now, and we have some PWM code hooked up, and we have one fan hooked up, which only pulls a few amps. But we're going to begin our initial testing. So currently we have the 4-channel thermocouple hooked up, and channels 1 and 2 are connected directly to the top of the MOSFETs. So you can see up here, that little blue wire is going to the top MOSFET, and then this other one buried in there, that's our second MOSFET. So we'll get some temperature readings on those MOSFETs under load. And we have, just right here, we got an amp meter. This will show us the volts and amps going out. It's our supply. And over here we got an oscilloscope, so we can see the duty cycle of the PWM frequency. So we're going to turn the supply on and begin testing and see what happens with the temps. So we're starting off as a reference right around 74 for pretty much everything. There's our scope showing the PWM change. So we've only got one fan hooked up right now, so it's not going to pull a lot of power. Get you over to the amp meter. That's 100% duty cycle, so we're only pulling 6 amps. Not a lot of power. Now we actually have the voltage low. We should turn that up. Alright, we're going to put the voltage up to 15. We got our voltage maxed out. We'll see what the current looks like on the next one. Here's our temps. So 1 and 2 did come up. We're maybe a degree. So we'll see what that does on the next one. So 74.8 and 74.7. And then we got about 74 for the baseline. So the baseline, we got these two thermocouples just to the left of the board. One's touching the mat and one's in free air, a little bit above the mat. There's our thing. I'll watch this temp. 75.2, just over a degree. Both of them are 75.2. We're pulling right around 9 amps. So 9 amps, we climbed up 1.2 degrees above ambient, which is 9 amps is almost 20% of the design target. That's not too bad. We'll see how this does over time. Yeah, that's our first test. Probably let this run for a few minutes, and then we'll hook up some additional load and repeat the test. Alright, so this has been running for 5 or 10 minutes. We changed up the thermocouples a little bit. So 1 and 2 are showing the MOSFETs. Thermocouple 3 is the PCB temperature. So we put a probe right between the MOSFETs. That's the third one, just in front of the lead for the oscilloscope. That one right there in the center, that's measuring board temperature. So 1 and 2 are MOSFETs, 3 is board temperature, and the fourth one is ambient, which is that thermocouple that's lifted up off the table about 1/2 of an inch. So we can see everything is starting to heat up with, we've been running a 9 amp load for 5 or 10 minutes. So we're about 4 to 5 degrees above ambient, 4.5 degrees above ambient. But the good news is the MOSFETs and the PCB are functionally the same temperature. So it looks like they are spreading their heat out to the board and they're not getting super hot on their own. Okay, so we've been running this at about 9 amps for 15 minutes. And here's our temperatures. They seem to have stabilized at this point. So we're right around 80 degrees for the MOSFETs and the board, and our ambient is showing up at 74. So we're 6 degrees above ambient, and it seems to have stabilized at this point. So this is a capture of the signal coming off the gate drive going over to one of the MOSFETs. So here you can see it's going from high to low. We're at 10 nanos per division. We can see it's dropping really quick. Kind of the number for 10% to 90%. We calculated it should be 27. And I'm not really sure exactly where the 10% mark is. If it's right in the middle, then this is 20 nanoseconds. If it goes all the way to the next division, that'd be 30. So we calculated it'd be 27.5 based off of previous measurements and the improvements we expected. So it looks like we're probably hitting that number, and it could be better. If it's down to 10% where it crosses, I don't think it's quite there yet. So we may not be hitting 20, but I'd say we're hitting around 30 nanos or less for the switching time. So this is a huge improvement. We had about 230 before. It looks like we're down to about 30. So much better. All right, here's our next test. So we added another fuse. We got 40 amps fused, and we hooked a second wire up to our fan positive. So now we're going to be running both eBay fans at the same time. So this will more or less double the current. From before we had close to 9, we should have close to 18. So we're probably looking at 17 to 18 amps. And we're about to start the test. Everything's around, ambient's about 75, board's around 77. Hasn't cooled off all the way. But here we go. These are our peak temperatures. We're running 16.5 amps right now. Their MOSFETs are 83, 84. Board's about 85. Ambient 76. So looks like we're running, what, 8 degrees above ambient on the MOSFETs. Oh, about to turn it up. Alright, so we're testing the large eBay fan, and we're showing 84, ambient 75, temps 84, so we're 9 over ambient. Here's our volts and current. That's our max, around 22 amps. Well, 9.5 above ambient. Go on to a higher current test next. So this is one spell fan and eBay fan, showing ambient of close to 77. MOSFETs are about 89. That's what, 12 degrees, maybe 13 above ambient. Here's our amp meter, going up to about 30 amps. There we go, 30, 30.5. Yep, so about 13 above ambient for 30 amps. So we got 2 eBay fans and a SPAL fan. I think the highest we saw was 94.8 with an ambient of about 76. That's what, 76 to 95. Got 19 degrees. About 38 amps. Perfect timing. That's showing 20 above. So yeah, 38 amps and 20 above ambient. Okay, so time for a not so awesome update. So we ran this at 50 amps a few minutes ago, and we have the scope hooked up, we have the temperatures hooked up. So we're sitting here running this, and it starts making a weird noise, and we've seen this noise before, and in the scope you'd see some noise coming up where the MOSFET has this little thing where it just jumps up and down for some reason. Not sure what's causing that yet, but we've noticed it's been happening, but it's barely happens at all. But when we got up to 50 amps, I noticed it did it more on the first sweep, more on the second sweep. And I think on the third or fourth, it did it a lot. And we saw basically the MOSFET turning on and off when it's not supposed to. And of course, the temperature started climbing. And then by the fourth sweep, it was going crazy. And I watched the scope. You could see the noise was really bad. And the thermocouples, the temperatures were climbing very quickly. So something's going on. We killed the power at that point and aborted the test. And I grabbed my little Okay, so we shut off the power supply, gave it maybe 10 seconds, and I managed to grab this temp gun. I started checking the board, and that power supply, that little 3-pin not SOT 23, that little guy was 150 degrees. So it was pretty dang hot, and this little gate drive was pretty warm. I forget the number. I think 117. Should probably have that in front of me. So anyway, my guess is that that regulator got way too hot for an unknown reason, and it was cutting out. And this chip, if voltage gets low, it shuts all the gates off. So my guess is it was shutting everything down, and this thing was, the regulator was probably going into thermal protection, and then it kicks out, and then this turns back on, and then these turn back on, and probably some weird feedback loop like that. And that's what was causing that. Not sure, gonna have to look into it and retest. So we've hit a snag. Gonna have to figure this one out. Hopefully, I'm guessing that regulator's undersized. I don't know, maybe maybe the power requirements for these gate drives, because they're so beefy compared to before, they're actually pulling a lot more power than before. So maybe that's just an inadequate supply now. So I'll give you a better update when I have some more info. Maybe I'll figure out what's causing this. So that's all I got for now.